What's the lowest single-celled organism? How long ago do we think that emerged?
I think current estimates are that life, like the oldest fossils that we can identify and like tracing back genomically, about 3.8 billion years ago.
So essentially somewhere around a billion or so years that we can find from the time Earth was formed?
Yeah, so Earth we think formed between 4.5 and 4 billion years ago. So like 4 billion years ago we kind of had Earth as we understand it. Mostly now we don't know if there were oceans, but the moon forming impact had happened.
That's Earth 1 and Earth 2, the impact with some other planet?
Yeah, Theia I think it was called.
Yeah.
Just smacked into Earth and then made our moon. Must have been really traumatic.
Imagine.
So I think most people think like life didn't happen before that, because if it did, it would have been obliterated. But we really don't know. So yeah, current estimates are around like 4 to 3.7, 3.8 billion years ago.
So somewhere a billion or less than a billion years later, something emerges.
Yes.
And how do we think that happened?
There is no consensus.
Ooh.
None. Yeah, I know. Isn't that fun? It's fun.
Yeah, it's kind of crazy.
It's totally crazy. That's why I like this problem, because nobody knows what happened.
Wow.
And
so
there's
what
a lot
are the
of
primary theories?
There's a lot of speculation. The sort of canonical ones that you'll hear about are usually like the RNA world, that life started with an RNA molecule, which like RNA is still in our bodies today. So like DNA, most people are probably familiar with, gets translated, transcribed into RNA, and then the RNA is what's used to make proteins. So RNA, kind of does a dual role. So people think, oh, maybe it happened early on and it was the first life. And then there's like other hypotheses like hydrothermal vents and, sort of energy first approaches to origins of life, that like we had some metabolism that was organizing. But all of these are really speculative. And I think the issue is that we're trying to take molecules that are in modern living systems and trying to understand how they could emerge in a prebiotic environment on early Earth, and not really thinking about how the Earth and the geochemistry on the Earth had to evolve into a living system. So it had like selection had to happen, evolution had to happen before life. And this is sort of the critical gap that we're really missing, is like, what is that mechanism? And that's where assembly theory is supposed to be coming in, is trying to give us a mechanism for how chemical systems can evolve before we even have a living cell, for example, and trying to iterate what those missing stages are, because we just don't know what they look like right now.
Well, also, what would the evolutionary advantage of becoming a cell be?
I think, so that's a great question, but one of the problems with this area is like we don't know what questions to ask. So I actually don't know that that's the right question. I think when you think about it much more deeply about like the physics of life and the way that we've been describing it already, if you think what life is doing as a mechanism in the universe is maximizing the amount of stuff that gets to exist, for example. Like there's this whole world of complex objects that cannot exist unless there's a living architecture that can select and constrain the space to make something like this, instead of like the universes of other things those atoms could be arranged in. So if you think that there's something that deep and that fundamental about the nature of life, the origin of life transition has something to do with the emergence of systems that basically can persist. They can survive against this sort of random chemical noise. Like the chemical soup is just a mess of things being created and destroyed. And you get something that basically can reinforce its own existence enough to keep existing, and then building more complex stuff. And that's really the origin of life transition. Is pretty simple to say like that, but trying to build an experiment and understand the sort of chemical architecture that mediates that transition is quite hard. And that's where we're at right now.
And so experiments are being done to try
Yes.
How do they conduct these?
So that's my collaborator, Lee Cronin, is a chemist, and he's totally brilliant. And actually, him and I are probably, I don't know, like what we're trying to do is a little bit crazy to solve the origin of life. But, I hadn't, he's doing the experimental stuff, but like the sort of idea we had in mind is like, I'll write a book, try to get the ideas out there, get people excited about thinking about this space, and he'll start a company that will digitize chemistry and try to raise the funds to actually do the experiments. So he's trying to build the technology and the experiments. It's built on this platform he has for building robots that basically do the chemistry for you. And the idea being, if we could build a large enough experiment, we could search that huge space of chemistry, a little bit like a search algorithm for chemistry, and then be able to look in chemical space and try to discover aliens.
Whoa.
In an origin of life experiment on Earth. And so that's what we're trying to do.
Whoa.
I'm really excited. I hope it happens.
Imagine if you guys, if someone does something like this, maybe it's you, maybe it's someone else, someone does something like this and creates an artificial life form and then starts manipulating that life form and evolving that life form.
Yes.
Through
That's the aim.
some extraneous processes.
Yeah. So, I mean, there are benefits to that, right? So Lee's company, Chemify, is a digital chemistry company, and their stated aim is to be able to 3D print any molecule on demand, right? So this has huge impact for the pharmaceutical industry, but like the real goal is to make an artificial life form in the lab. But that also has huge impact for humanity, because you imagine that now you have the ability to study in this other system all of these other kinds of chemistries. Like, what can you do for like antibiotic discovery or pharmaceutical drug discovery, or even psychedelic drug discovery, if people like that. But you know, like there's a crazy amount of new technology and new insights fundamentally to come out of that. But I also don't think that we're really going to understand these other kind of technologies that we're building, like when we're thinking about artificial intelligence and like, is that alive or not, unless we solve this chemical problem of what life is. Because I think the chemical problem is much harder, but much more direct as far as like understanding the fundamental nature of life when you solve it in an experimental program.
Biological life.
Biological life. Chemical life. Because it won't be biology as we know it, right? That's the whole point.
Right, that's
It'll
the
be
point.
alien biology that we evolve in the lab.
Right.
And I actually think this is how we're going to make first contact with alien life, because I think we won't recognize it unless we understand what it is.
Wow. No, what ethical concerns would arise when you take a thing, like let's say, let's advance this whole process a few hundred years from now, and you've created artificial life, you've created this thing that doesn't exist anywhere else, and then instead of it being subject to natural selection as a vehicle for its advancement, instead we just start fucking with it.
Yeah.
And then it gets to a point where there's an ethical concern, like, hey, this thing's about to get smarter than us. What do we do?
I think there's ethical concerns right along the way, and I don't know that I know immediate answers to those. So it's kind of like, this is the part where it's a little existentially traumatic to work on these kind of problems. So I have a friend that's a philosopher, Ben Bratton, and he says the best kind of like ideas are the ones that are like equally like really exciting and horrifying. And like, you want to work on those ideas because you don't know what its like future is going to be. And I tend to be on the optimistic side. I think we need to solve this problem because I think we have this sort of existential crisis in some sense that humanity is facing, because we don't understand what we are. We don't understand what our technologies are doing. We don't understand what our long-term future holds. We don't even understand all the life around us on this planet. So we solve that problem. I think that the lens through which we will look at the kind of ethical things that you're talking about will be radically different, because the knowledge itself will have transformed us. So I can't even anticipate what those kind of dialogues are going to be like. Imagine if, like, instead of just wondering about cephalopods and plants and stuff in this conversation, we actually had a fundamental understanding of what it is to be other life forms and life as a as part of the fundamental structure of reality, and like participatory in actually like what the universe builds. And you have that kind of understanding. I think it radically changes the way that we conceptualize who we are and what we're doing. And I don't know what that looks like.
And we would assume that if we continue, especially down the path of AI,